So let's just look at first the Oracle client. And I don't want to go into detail here because I mean the point is not to show you how to write a front end, just give you the general idea. So actually I'm using a Haskell library called REQ or rec request to do these web requests. So what I do in the main program is I read this file to get the UUID that has the correct instance. Just log that and then go to go. And this loops forever. And what it does, it looks up the current exchange rate, ADA US dollar on CoinMarketCap, checks whether that has changed. So this parameter here is the old value that starts with nothing. In the beginning, I don't have any. So then it checks the new exchange rate. And if this exchange rate has changed, it calls update Oracle. We'll get to that in a second. So that calls the update Oracle endpoint on our contract that we defined before. Then it waits for 5 seconds and loops. This is, of course, arbitrary. I don't know whether CoinMarketCap does some sort of rate throttling. So I didn't want to risk being banned for having too many requests. So I just did it 5 seconds. In reality, seeing as blocks on Cardano only appear every 20 seconds on average, probably even 5 seconds is too much and should rather be 20 seconds. But anyway. So this Oracle update Oracle is now the interesting one, where I demonstrate how to interact with the running contract. So this stuff here is just comes from this REQ package, so that's not important. But basically the essence of what I'm doing is I prepare post request. So I go to my local server with this endpoint we just saw in the API module. So API, new contract instance. Then the next parameter is this UUID. So I just convert it to text. Then endpoint, the name of the endpoint which was update. And now I must provide the request body in JSON format of the value I want to update to. That is this X. And this just says that I expect a JSON format response, and this gives the port. And then if that goes well, so if the status code is 200, I just log a message accordingly. And that's it. And as I said, the details don't matter. You can do that in the programming language of your choice. It's just a plain old vanilla HTTP endpoint. And this here is my very quick and dirty way to get the actual ADA US dollar exchange rate from CoinMarketCap. Of course, they also provide a proper API, but I just basically get the whole website for currencies Cardano and then use a regular expression, which of course is very fragile and would never work as production code, just to grab the exchange rate. And basically that's it. And then I just multiply it by 1 million and round it to get this integer value we want to use and log a message. So we can try that out. Let me just start the PAB again. Wait until the Oracle is started. And the funds are distributed. Okay, so now everything should be running. And let me just go to another terminal window, and I run the second executable that I just showed you, the Oracle client. Okay, now it went to CoinMarketCap, and it seems right now the exchange rate is $1.75. And now it called update Oracle with this 1,750,000 value. If we switch back to where the PAB runs, we see that we also get log messages for this. So this update transaction that updates the Oracle UTXO has actually been received and processed. And we also get the correct log message that we saw earlier in the core module, that the initial Oracle value was set to 1.75. Now, of course, I have no control over the exchange rate. So I don't know whether this will change from 175 anytime soon. Maybe while we wait for that, we look at the swap client, which is very similar, so that people can actually, sorry, it's so that uses the same technique, same REQ library to handle HTTP. And the idea is I just want to offer a very simple console interface. So I didn't bother with graphics or a nice web UI. It's just console based. So the idea is I just want to offer these 4 possibilities. You can make an offer, you can retrieve, you can use, or you can check your funds, and it loops forever. So I don't have to go into that in detail. It's same thing here. One difference is I actually provide a command line parameter because I want to run these clients for different wallets. So I provide the wallet number as a command line parameter. Then I read the correct UUID from the file and log something and then loop forever. And this loop, all it does is it just passes this command that I enter by text from the console and then calls the appropriate endpoint. And this endpoint calling is defined here, and it's basically always the same thing. But for example, for get funds, we want information out of the web interface, so we must use this status endpoint. So we call the funds endpoint. And then remember in the funds endpoint in the swap contract, what it did, it checks its own funds and then tells them. So here we check them, and now we do a second request where we use the status endpoint to get the status of that instance. And then we basically can extract the observable state from that. So we just have to, so we get the response body, then have to apply CIC current state and then observable state, and then pass that from JSON. And if all goes well, then finally we get our value that the contract told. So that's how you get information back out of a contract. And offer, the others are simpler because we don't need information out. So we only have to do one request where we call the appropriate endpoint that we defined earlier in the contract monad. So this is for offer, this is for retrieve, and this is for use. And once again, the details here don't matter. You just need the programming language of your choice that allows you to do post requests and get requests and handle request bodies and so on. So let's see whether the exchange rate has changed. No, it's still 175. So we're still at our initial value. But nevertheless, let's start this client as well. So cabal run swap client, and you pass command line. If you use cabal run and on command line parameters, you have to do double dash and then the parameter. So this will execute this executable I just showed you for wallet 2. So let's do that, and let's also do it for wallet 3. Okay, and now I have this primitive console interface. So now I can issue these commands. And actually I forgot, I just see that I missed the funds here. So I not only have offer, retrieve, and use, I also have funds. So I could change that, of course. Here. Okay. Let's try that again, that we get the proper help message. Let's see whether, no, exchange rate is still, now it just changed. So now it changed from 175 to 176, and we called the update endpoint on our contract. And if we switch back to the PAB, now we see a log message here that updated Oracle value to 176. So now the UTXO on the blockchain changed from having 1,750,000 to 1,760,000. Okay, now we should be able to try it. So this is now wallet 2. Let's start with the funds command. Okay, and I still have all my initial funds, so $100 US, 100 ADA. I can do that for the other wallet as well. Great. Don't know what went wrong there, but anyway, so same thing here, $100 US, 100 ADA. Now let's switch back to wallet 2 and let's offer a swap. So offer, let's say 10 ADA. So 10, 1, 2, 3, 1, 2, 3. So now if I call funds again, there's a difference. So I still have all my US dollar, but now I have 10 ADA less and a bit for the transaction fee. If we switch back to the PAB, we should see that something happened here. So a couple of own fund endpoints were called, and we get these log messages that the offer was made. Let's just check what the current exchange rate is. Okay, it's still 176. So if I now go to the other wallet, to wallet 3, and call use, I should be able to exchange those 10 ADA for $17.60. Let's see. Okay, now let's check the funds here. Okay, that hasn't updated yet. Sorry. Takes a while. Okay, now it has updated. So now I have more ADA. I got the swap was 10 ADA. So I got the 10, but in order to use the Oracle, I had to pay 1 ADA Oracle fee. So that's why I only have 9. And I have a little bit less because I had to pay transaction fees as well. And in exchange, I had to pay $17.60. So now if we switch to the original wallet that did the swap and do funds, then hopefully that will have changed as well. Right. So that now got the $17.60. So the swap is complete. And the correct value of the exchange rate, the actual live, right now exchange rate US dollar to ADA was used, which was injected into the mock blockchain via my Oracle. So now you have seen end-to-end example of a Plutus D app from front end. So it talks to the outside world, goes on the internet, gets information, interacts with Plutus smart contracts, which then submit certain transactions to the blockchain, and then on the blockchain, the validation logic kicks in and makes sure that everything follows the business rules. So this is a complete walkthrough from on-chain code over off-chain code over PAB code to front end. And as I said, it's very similar to what the real system will look like, at least in the beginning, until we have like a browser-based way to interact with Plutus. The only difference, of course, is because now it's this mock chain, I only have one instance of the PAB running, and all my simulated wallets use the same server, which of course in real life would be silly. So obviously different wallets will have different instances of PAB running. But now it has to be one instance because otherwise, because there is no real blockchain. So this one PAB instance holds the simulated blockchain. So this is slightly different. But if you squint a bit and forget about that, it's almost exactly end-to-end how the real system will work in the beginning.